All right, let's dive right into this comprehensive explainer, where we are finally settling the ultimate 2026 data career debate. Look, if you're watching the data landscape right now, you already know the ground is completely shifting beneath our feet. I mean, headlines are screaming about AI automating coding jobs, but then at the exact same time, reports are showing millions of new openings in data. It's a really confusing time to map out a career path, right? So today, we've prepared a highly detailed breakdown pulling from all the top industry resources. We're talking the Bureau of Labor Statistics, Analytic Vidya, expert insights from practitioners like Honest Riyadh, and the Lore So What channel, and curriculum roadmaps from Knowledge Hut. We're cutting through all the noise to show you the exact differences, the gritty realities, the pay, and absolutely how to guarantee you become indispensable.
We have a lot of crucial ground to cover today. Here is our roadmap. We'll start with the great data divide, look at expectations versus reality, check out the pay and outlook, tackle the AI automation threat, and finish up with future-proofing your career. Let's just get straight to it.
Section 1. The Great Data Divide, Past versus Future. Let's cleanly separate these two distinct paths right out of the gate. It's incredibly easy to get the titles mixed up, but fundamentally they operate on completely different timelines. The absolutely crucial point here is that analysts map the historical roadblocks, while scientists build the engines that autonomously predict the future. Think of a data analyst like the person programming a GPS for a business. They're looking at historical data, past traffic patterns and real-time roadblocks, to give the company the fastest route to success. They answer, what happened and why do we lose that customer? A data scientist, on the other hand, they are building the self-driving car itself. They use heavy coding, predictive analytics, and machine learning models to actually forecast what will happen next. It's like the algorithm that autonomously recommends what you should binge watch next on Netflix.
A data scientist really sits right at this complex intersection of math, computer science, and domain knowledge, acting as the ultimate bridge between all three. According to a breakdown from Analytics Vidya, a data analyst relies heavily on that domain knowledge and some math, really focusing on communication and visualization. But a data scientist, that requires a much deeper dive into computer science. We're talking multivariable calculus, linear algebra, and complex machine learning architectures to build out those predictive models.
Moving right along to Section 2, Expectations versus Reality. Let's break some myths here because, let's be honest, the job descriptions often lie.
The contrast when you compare these side by side is pretty stark. The barrier to entry for an analyst is significantly lower. You can honestly become job ready in about 3 to 6 months if you focus hard on SQL, Excel, and visualization tools like Tableau. But data science, that requires a much steeper learning curve. You're often looking at 6 to 18 months just to master the foundations of machine learning, assuming you don't already need a master's degree. But you know what the biggest shock is for most people? The daily reality. While analytics is highly social and requires constant stakeholder communication to figure out business problems, data science is incredibly technical. It can actually leave you working totally behind the scenes, pretty isolated in your code.
And here is a bit of a harsh truth that a lot of aspiring data scientists end up facing. You might go into the job expecting to build these super sexy deep learning algorithms, but actually, you just end up cleaning messy data all day. As the YouTube channel Lore So What points out from their years of industry experience, a lot of companies just aren't mature enough for advanced AI yet. They just aren't. So data scientists often find themselves acting as glorified data janitors, just trying to get unstructured data into the cloud before they can ever run a single predictive model. Analysts conversely usually have a much better alignment between what they expected to do and their actual day-to-day reporting duties.
All right, Section 3, the pay and the outlook. Despite those gritty realities we just talked about, let's follow the money.
34%. The U.S. Bureau of Labor Statistics projects a massive 34% job growth for data scientists between 2024 and 2034. To put that into perspective for you, the average growth rate for all occupations is just 3%. That is absolutely wild. We are looking at roughly 23,400 brand new openings every single year just for data scientists. The demand for data-driven decision-making is quite literally exploding.
Furthermore, with 88% of businesses now integrating AI into their operations, we are seeing a 60% supply-demand gap for these roles. According to resources from Skillify and Karmic Institute, there's a massive talent shortage globally. So what does this actually mean for you? It means the leverage is entirely in your hands. Companies are desperate for people who can actually make sense of their data lakes.
When you look across the global markets, it's super clear that while both paths are very lucrative, data science commands a massive premium, mostly because of that steep learning curve we mentioned earlier. Whether you're looking at US markets with median salaries easily hitting 6 figures, or the booming tech hubs in India offering up to 60 lakhs per annum for senior talent, the financial ceiling for data science is incredibly high. But honestly, do not discount the analyst path. It offers a fantastic, high-paying entry point that gets your foot in the door of the industry much faster.
Now for Section 4, the AI automation threat. Who survives? Because we really can't talk about a 2026 career without addressing the giant elephant in the room, generative AI.
Look, if your entire job consists of repetitive, linear tasks like writing basic SQL, running simple analytics, or spinning up standard dashboards, AI tools like ChatGPT and Claude can already automate your workload today. Seriously, if AI can define the task, AI can perform the task. Knowing basic Python is just no longer a competitive edge because AI can write the code faster than you can. If your day is just creating simple dashboards on top of existing data, you are at severe risk.
So, to survive, you absolutely must understand complex, unautomatable frameworks like MLOps. AI cannot own a production system end-to-end. It cannot decide when a model is drifting and needs retraining. It doesn't understand the real-world constraints of business cost and latency. MLOps is what ensures these models don't just break when faced with unpredictable real-world users, utilizing tools like Docker and continuous integration pipelines. AI simply cannot hold these complex architectures together on its own.
As AI engineer Anas Riyad explains it, the divide is actually really simple. AI can generate code and it can optimize tasks, but only humans can own and maintain the entire architectural system. The people who are safe aren't the ones who just know the most Python syntax. They're the ones who think in systems. They're the ones designing the pipelines, deploying to the cloud, and translating vague, messy business problems into hard data solutions. Which brings us to our final section. Section 5, Future-Proofing Your Career. Here is your roadmap.
So, how do you equip yourself with the armor needed to become a system owner? According to the Knowledge Hut Transition Roadmap, making the leap successfully means methodically moving from basic reporting tools into cloud architecture and deployment, usually over a 9 to 12-month period. First, you start by deepening your Python and stats. Then, step 2, you practice those core ML algorithms. Crucially, in Phase 3, you have to move beyond your local machine and learn AWS or Azure, along with Docker, so you can actually handle big data. Finally, you must build end-to-end projects that prove you can take messy data, clean it, train a model, and successfully deploy it into production.
Again, AI generates code, humans own the system. You have to use AI to go faster, not to avoid going deeper into the technical architecture. Let AI be your co-pilot to write that boilerplate SQL or to debug your Python, for sure. But you must be the architect who understands exactly how the data flows from extraction to inference to monitoring. You need to be able to talk about business impact, not just model accuracy. Ultimately, your job security relies entirely on your answer to this single critical question. The data landscape of 2026 is brutally efficient, there's no doubt about it. But it is also incredibly rewarding for the people who step up to the challenge. Whether you choose the strategic, stakeholder-driven path of a data analyst or the highly technical, predictive realm of a data scientist, you have to stop thinking about individual tasks and start thinking about the whole system. So I'll leave you with this. In 2026, will you optimize for a replaceable task or will you own the system? Thank you so much for joining me for this explainer, and I really hope this gives you the clarity and the resources you need to make your next big career move.